Greetings, ladies and gentlemen. Thank you for joining us for our new episode of AEC Automation Success Stories. I'm Yasha Moradi, your host today, and I see a lot of known names and a lot of new names. So I welcome all of you on board to our journey today. So for getting the best viewing experience, please open the view menu on your Teams and choose the speaker view. And with that, basically you will get the best viewing experience and in full screen. And without further ado, just go into our agenda. So we go through a round of introductions, and then we invite our valued guests, Zakib, to present us the 5 strategies of creating generative design environments, and then we open the stage for everybody to a round of Q&A. And in the round of Q&A, everybody can basically raise their hands and ask their questions. I will unmute people who raise their hands, or if you have any questions during the presentation, feel free to put it in the chat. When we are done with the presentation, then we basically read the questions one by one and go through them. So to give you a brief introduction, my name is Yashar. I'm a civil engineer and software architect, and been in the industry for the past 28 plus years. In AEC industry, especially in spatial industry. I've been busy as CTO and tech lead in companies for reality capture and geographical information systems, space tech, prop tech, and now I am a co-founder and CTO at Bimondis. What we do at Bimondis, I don't get into too much marketing. It's basically we're trying to help our industry to go through this digital transformation, and in our opinion, the digital transformation starts with people, and that's why we focus our forces mainly on at the moment 2 aspects. One is our AEC Coding and Automation School to teach people how the digitalization should work, and we see digitalization not only as archiving everything in digital format, but rather to be able to use it efficiently, use it productively, and use automation. And we also have a network of freelance experts, and we believe in the idea that we don't have any lack of experts. We just have bad distribution of the experts. So if you look internationally, you can basically get the expertise that you require on demand, like in all the other digital domains in the industry today. And you can basically learn from these experts and go on your way with a new experience. Our valued guest today is Zakib Aziz, and he's a very accomplished architect and a very experienced digitalization expert as well. He is an educator in University of Arts in Berlin, and he has extensive hands-on experience in computational design, generative design, and also robotic fabrication. We have the honor to have Zakib also as one of our trainers in our AEC Coding and Automation School for Rhino and Grasshopper trainings. So welcome on board, Zakib. So Zakib, we are going through your presentation as the next point, but I just wanted to, before we go into it, I just wanted to ask you if you were going to give everybody one takeaway tip. What would that be? One actionable insight that our audience can use tomorrow in their day-to-day work life.
Yeah, so first of all, hello everyone. I'm happy to be a part of this. So the one thing that I would take away is, as you said correctly, we have actually all the experts that we need to create very complex models, design systems. But the one thing that we're lacking is usable and applicable user interfaces that are easy to use and easy to navigate that allow a broader set of designers to actually engage with these programs. So it's not a lack of expertise, really. It's a lack of how we spread this information and make it usable for a larger audience to really promote innovation in a sense. Because you can then actually do collaborative design and approaches and have a better decision-making process.
Yeah, well said. Well said. We actually have a little bit of problem with your audio. It is going up and down a little bit. It might be from only on my side, but it would be great if you you keep near the microphone. And
Mhm.
yeah, with that, we can start the presentation. I'm looking forward to see your screen sharing.
I hope this is visible.
Perfect.
Perfect. So first of all, I want to thank the Bimondis team for inviting me to give this webinar. It's called Five Game-Changing Strategies for Creating Your Generative Design Environment. So it sounds very ambitious, but to put it in humble words, maybe is just five strategies that we saw or I saw in my career so far, both in industry and academia, that serve good solutions how to generate new design systems. And that is something that I was to share my experience so far with. And hope it's an exciting webinar. So, as I said, I have a background in architecture. I studied it here in Berlin, and then I was at Hen Architects as a computational design and environmental design specialist, and did a lot of competition work, but also had some um, had some experience with research endeavors, and that actually led to me coming back to the university and now pursuing my PhD in additive manufacturing and robotics. So this was one of the projects at Hen that brought me back to academia because I understood that through new
Zakib,
technology and
Zakib, just one quick question. Can you use headphones because your audio is breaking? I also have some comments from the audience.
I will try to maybe just get away from the Teams meeting. I think that was pretty good. So
Yep.
if that works,
Or
Yaza, you could just write to me quickly if the audio is now better because I don't see you anymore.
yeah, the audio is perfect. Audio is perfect.
Okay, super. So yeah, so I can't be in both realms as it seems. So yeah, just to make it brief, this was one of the projects that actually brought me back to academia. This is the first carbon concrete composite building in the world, as they claim. And this kind of fascination for new materials and new technology and how we then need to rethink the way that we design and the forms that we can generate, I found extremely interesting. And that's why I'm now pursuing the same kind of realm with additive manufacturing for new construction elements. But to really come back to our webinar, so the five strategies that I found is interesting and always a challenge in every design environment that I'm in so far is that first of all, there's a new kind of paradigm shift in the way that we create design environments. Beforehand, it was always geared to one solution, an outcome, and I think now with generative design, we have the opportunities to create larger ecosystems or design environments that allow us to create different solutions or results. And it's interesting that the architect or designer are actually becoming more and more programmers, if you will, creating worlds that other people can explore and then create their own design out of it. And that leads to the second strategy is okay, if we have experts that are very skilled in those kind of design environments, let it be generative design, some of you know Rhino Grasshopper, you can do very complex things with it, but how can we make it possible that other users can also use it? Because otherwise we only have a small group of experts that are able to actually function in that world, and others are kind of excluded out of it. And I think that is not very beneficial to kind of really promote innovation and collaborative design. And the other two things, 3 and 4, are a bit more like a black box or a bit more hidden. That's something that maybe the users who use your design environment do not see. But the interesting thing is, how complex can your system be in terms of allowing different strands of design options also to branch off of one design system. And of course, this is then included and evaluated with embedded optimization requirements. So whenever you have a design system, you have to have limitations of what a solution actually is feasible or not. And then the last one actually is streamlining fabrication. This could be like fabrication in prototypes, physical prototypes. This could also be streamlining reporting mechanisms, or how to create a streamlined way to create drawing plans, etc. And of course, this, I think, is a very interesting iterative loop that always kind of builds on each other and kind of facilitates each other. And the one thing that I really want to emphasize here, and the big takeaway, is what I find crucial in this situation right now is that we have the challenge of a easy to use user interface. And this can be like mapped to all different problems and challenges, but ideally, if you really want a larger audience or designer group, stakeholders, to be able to work with your design solution and find themselves able to navigate in them, you need to create now new user interfaces, because we're not only creating drawings, we're creating applications which user should be able to navigate in a fun and inviting, intuitive way. So this is something that I really want to emphasize, that I think the experts are there in all of the industry that you can find, but emphasis should be made of how we can invite other designers to engage and actually explore more complex design operations. I want to explore this on 3 projects. Actually, they are iteratively built upon each other and show a bit of my career so far. So we will start with an art installation, which is called Communication Landscapes. We will jump to a pop-up factory, which is a bit more exploring how we could use new technologies in the construction industry. And then the last project is actually hands-on construction industry relevant, where we kind of prototype new construction elements and use new technology to actually create geometry and prototypes that could have not been done otherwise. So I will hope that I can explain what I find crucial strategies along those 3 projects. Just to say that this current, what I'm going to present today, has also been published in Architecture and Design for Industry 4.0 just recently. So just to show that whatever we do, we have the aim to actually have it peer reviewed and share our knowledge with a variety and a larger set of researchers to just contribute to the ongoing development in research and innovation in our field. And our paper is called Programming Design Environments to Foster Human-Machine Experiences, because one of the crucial things that we want to emphasize is we have new technology, but someone has to operate that. And usually there are non-experts. So we call them kind of, a colleague of mine, Giovanni Betti, coined it very nicely. He said NERO, so basically non-experts, robot operators. But that is something just on the side. And the one biggest takeaway, again, just to say it in one sentence, is to promote democratic and collaborative design. And it is essential to guarantee that your generative design environments and the tools remain accessible to every team member, so nobody's excluded. And it doesn't really matter what their technical proficiency is, and they can hereby accelerate innovation and decision-making process as a unit and as a whole and as a bigger ecosystem, instead of just a few, many that can contribute to this field. So now I would quickly jump to the overall concepts that we found interesting. Is that one thing that we found is that innovation and research usually in our current time was always light in the outer skirts of a city. So you have big industry clients or partners or companies that basically have their facilities where they construct or build or manufacture their goods outside of the city, and the normal user or people cannot really engage and see this new technology advancements. And we found that very interesting and find that there's a paradigm shift here also, that now more and more is coming back to the city, and basically we are able to give everyone access to these new technologies, may it be robotics or additive manufacturing, 3D printing. And that actually changes the way that we build and consume or create products, basically. This can be seen very, very briefly in the way that we have our Industrial Revolution, and then the other phases that came after that, really exploring that we have this whole sequence of automation that we just actually ran through, and the IT systems enabling to scale up immensely the overall production sequence. And now what we have is the fourth revolution, which is basically cyber and physical systems, Internet of Things. Everything is connected and kind of is intelligent enough to learn from itself and kind of exponentially build up an archive of knowledge that ideally everyone should have access to. So what we found is that, or why it is relevant, is that craftsmanship, basically, it kind of got streamlined in a way that only bigger companies could really engage or buy state-of-the-art industry machines, and could then actually prosper their innovation because they have access to large production facilities, and that the craftsmanship or the craftsman itself, that whole, let's say, profession got kind of eliminated, I would say, or it got reduced to a large degree. And now the idea, if you bring back this knowledge and make it feasible to people to engage with new technology, you can create a new artisan that can explore new products and design them on a human scale. Basically, as you know, with Fab Labs, where you can basically go and you have 3D printers, you can test out new ideas of a product that you have, and you can then actually create a startup much more faster than I would say a few years ago, which is very exciting. And that's because we have now access to those technologies and to the knowledge also that is embedded. And I think there are very much interesting projects that explore that, where this big research and development facilities come back to the city, and actually they want to promote the idea of exchanging their innovation with people, basically thinking about, this is the Gläserne Manufaktur, basically inviting people to showcase and see how, let's say, cars are made and what kind of new technological advancements we have that shape up this new design system, and really maybe inspire a new set of entrepreneurs, if you will, to engage with that. So what we have now is basically a new design system and new set of tools. And one of them, of course, is the accessibility to robots, as we can understand to be a Swiss knife of applications that you can do with it. And that is obviously one of the things that I really wanted to concentrate on in my further career. And another interesting application or technology that we also have, as you all know, is the use of virtual reality, or in our case, mixed reality, which actually changes the overall way we show or communicate information. Basically, as you can see, we have holographic interfaces that are spatially placed, and you can actually engage with that, which is super interesting. So we have two different new strands. Just, of course, we have AI and everything, but in the construction industry, I think these two are the ones that are currently trying to do the transfer into like applicable solutions. The first demonstrator or project that I want to show is a art project, art installation that we were invited at the Seoul Biennale to contribute to a exhibition that took place over a few days. And we want to really explore this idea of collaborative design, and how you can actually create design systems and user interfaces that even children can use. It has a very complex background or back end, let's say, but the front end should be so easy to use that even a child can actually produce an object and make the robot cut that object with few clicks. So this is basically, again, built on the notion that generative design can offer an unlimited supply of solutions and with unlimited, basically, parameters. But how do you break it down, make it as easy as possible to use, to have the clear idea of what good can be actually resulted from it? So this, again, the idea that we have this shift maybe now into a new craft that we can explore because we have accessibility to new technologies. And as you can see with the robots and VR, even industry partners or architectural firms, engineer firms have now access to these technologies and actually can explore and innovate in a sense, which I found interesting. So to come back to the 5 strategies, the new design environment was again to rethink the way that we would actually go about a problem. In this case, we didn't want to create an outcome which is a drawing or a model, but we wanted to create an environment where non-experts could engage with, and with a very easy and intuitive user face, create a good or a product. So that was kind of the experiment that we wanted to test. And the idea that we thought about is to use sound as the means of communication. So going away also from this notion that you need your mouse and your keyboard as the main means to interact with technology, but we have this sound input that can then form an object. This object can be cut immediately or in real time with a hot wire cutter, which is attached to a robot. And then a product, in this case, a foam of block, will be cut and processed, and you get basically a dynamic link of a production chain within seconds until the generation and then the fabrication. And this is the idea that we had to understand, that we have a design section, we have a production section, and we also want to disseminate this information. So the idea was that we want to build a structure that the participants, each of them, contributes to with their one individual piece of foam, and then this will be installed in a wall that is going to be built up in a few days. So the biggest question that we had is we programmed a very complex setup in using Rhinoceros and Grasshopper, which can actually in real time get the voice. It can actually then we programmed the hot wire cutter, how the robotic motion has to be controlled. But of course, you need to limit the information for the users because they don't want to be afraid of using it, because I think that is the biggest issue that we have is most non-experts are just overwhelmed by this new world of the generative design, because you have so many parameters and it can be so difficult to understand what is going on in a program that maybe they are just not willing to engage. So the idea was to really think about how do we gamify this user interface, and how do we use new means of input to actually make it more fun and make it kind of easier to engage with the setup. And again, we used the voice as a system because I think that is something we are more and more familiar with, using Siri, Cortana, depending on what operating system you use, to operate the design process. And this is the user interface that we did. Again, this is a bit long time ago that we did this, but basically you would see this foam of block, you would speak into the microphone, and depending on your frequency and volume, the shape would be generated, which is basically a wave shape. And you record, press the record button, and then once you're satisfied, you just click save configuration and the robot will start. So basically you have two inputs that you would need to do. You understand graphically what currently is making up this object, so you can actually modulate the design using the input of sound. And with 2 clicks, basically go through this process without understanding the overall design system in the back end, making it more fun and engageable for people to interact with. So, of course, there are a few things, enabling decision trees and embedded optimization. I would say this is a bit more hidden from the user. Of course, if you have a design system, it can be extremely complex. You need to ensure that from one design solution, you can generate a variety of solutions. So you need to really think about how these design systems are made and make them robust enough that even the user, whatever he does, you can't really create something which can't be fabricated. And that brings us to the embedded optimization that has to be done also, because you need to make sure that whatever design system you allow is within limitations to create a feasible result. So one of those systems that the user did not see was, for example, an aggregation clustering algorithm, which basically sorted those design pieces that we will see in a second to a neighboring strategy. So every block that was similar in shape and form would be clustered together, and this would create a very interesting kind of pattern along the installation wall, as you can see here. So we have foam blocks that look similar, kind of neighboring each other, and then from that we create this something a bit more of a complex, let's say, placing strategy. And fabrication, again, the same thing. So it is not a trivial task to operate a robot and create the overall print path, or let's say the G code for the robot to move. But again, we do not want the users to be afraid of the technology. And with a mouse click, they should be, or with a button click, they should be able to produce something that they understand right now, because it's basically shown in the user interface. So yeah, this is basically our achievement, that we had a child that came and interacted with this system and actually could then produce a product. And here's a small video that I wanted to quickly share of this process. So maybe, yeah, so I'll just narrate it myself. The sound is, I think, trivial. So this is the overall setup. We have this interface that is currently always working. We have the microphone as one of the biggest means to communicate with the interface. And the principle is similar. So you just speak into this microphone and your sound propagates a design solution, which is the formulation or the kind of design of the foam block. You can see in live basically how your input of voice will change the overall design of the shape. And once you're satisfied, you can basically just press a button and then a robot will cut exactly that form for you. So we kind of have different, more complex sequences and try to minimize the complexity as much as possible with this kind of system. And again, engaging the people that they have two artifacts that are created, a positive and a negative form block. One will be going into this ongoing installation of the wall, and the other one can be taken by the visitors as a souvenir. And basically, they can keep this memory forever if they want with them. So this was a very first example that we did, and we had some insights out of that. One of the biggest insights that we had is to understand that this placing of those form blocks was not a trivial task, because it was still manual, and I was there and did it myself, and I did some mistakes, as you do. So we thought, okay, how can we streamline this process of assembly also, and thinking about more about the construction industry that we want to actually target with this kind of design strategies. So we did a second example next year for the Make City Berlin festival called the Pop-Up Factory. Again, that was in my time at Hen. And this was exploring the similar concepts. So all of the voice input and design stayed the same, but we explored a bit more augmented reality and a different kind of user interface to go through all the steps and kind of assist you while you go through all the processes, and can rely on a, let's say, holographic environment of information. This is basically the task that we set to us. So if you come into this, if you would have come to this exhibition, you would see a physical realm, basically a robot standing there, and a small structure that is currently being built. And if you put on the HoloLens or the augmented reality goggles, you would see a different environment, a completely new information-rich, holographic and digital environment where you can interact with different icons and actually can propagate the different steps it takes to create, again, an ongoing sculpture that was built. One interesting thing here, you can see an image from the HoloLens. Interesting thing that we did is we wanted to explore the idea of the construction industry And therefore, whenever you build something, of course, it is physical and set, but the digital realm, you can still change while you're building it. So still here, you could change the anchors. In the video, you will see that. And the overall shape in the upper part can still be changed. So this is kind of the idea that you can still kind of interact with design, or this like in the construction site, if something goes wrong, you can still kind of manage it by slightly changing the overall design to take in anything that goes wrong maybe or is unexpected on the construction site. This brings me back to the idea that with our generative design strategies, we can build a much more dynamic link between the current different design phases. So we all know this. We have in Germany alone 7 different design stages with different teams each. So the early sketching or the design is done by a competition team, and then it goes to design development using a totally different software like BIM. And then this has to be processed and then just created into two-dimensional drawings, which then actually go on the fabrication site and are used by the contractors. And with this solution that we just want to show here is the idea of how we could actually create a dynamic loop between all of those phases and make them actually as one part in one design environment and system. And for that, again, the most crucial thing we found out is to have an appropriate user interface. So we really try to explore the user interface using this time holographic means or holographic overlays of information, 3D models, if you will, that you can basically just tangibly touch and something will be generated. So you have a design environment where you can basically design the overall shape by changing the position of those anchors on the top. You have the generation of the bricks that actually make up the structure. You can select how many bricks you want to build at once. You can decide how the surface texture is looking just by your voice. And you have the robot. Basically, you just press on the three-dimensional image of the robot, and it will basically create the robotic path to cut those foam blocks and exactly with the right angle that we need for your design solution. So it's, again, very complex strategies or routines, but you don't have to always display them to everyone. You just need to reduce the information as much as possible, so the overall design idea that somebody can build the structure, which is a non-expert who has just been introduced to this design environment, can still navigate himself or herself through the design process. So this is the video that I just wanted to quickly also show as a step 2, if you will. Again, we didn't know the result of the final structure, so it's kind of a co-authored design piece, if you will, which is also interesting. It brings both challenges and advantages, but it is really a collaborative effort to create something which is still interchangeable. So you have this beautiful goggles. You can then change the overall design, as we can see here. So if you choose just a bit of that, the remaining part that is not built will change. And if you want to then fabricate the bricks, you can again use your voice to create the texture and then press on the robot, and the robot motion will start immediately in real time to fabricate your 5 pieces. But this is not enough, because now we just have the production of the raw materials, if you will. The most interesting thing was how to communicate this information for the people, that they can then actually assemble it also. And that is how we did it then, basically with the holographic interface, first showing how these elements have to be aligned, and then showing how and where those pieces will be mounted, so you can then assemble them on site with various users. Now, I have to say, of course, this is not an easy task, because it is very, very challenging for non-experts to, first of all, take the glasses on them and then kind of navigate through this new design environment, because you have to learn basically new design inputs. We have the mouse and the keyboard. We're pretty much familiar with that, but using a new kind of design environment takes a bit of practice. So it is not always as easy as it might seem, because you need to educate the new user set to your user interface also a bit. So as I said, it is very important that we have new user interfaces, but also that takes a bit of practice and a bit of a learning curve to engage and feel free to navigate through these new interfaces. I can see I'm almost done with the time. I will kind of briefly rush to the next few slides. Just as to finish with the concept, so we really don't have this old idea of a mastermind determining, like controlling the way a product will look like or kind of propagating how design should be done. But what we have now is a kind of, with the new technology that we have kind of a swarm intelligence, if you will. Basically having a democratic and collaborative approach of how we can include more stakeholders and designers into your design system and approach, and contribute to a better decision-making process, and hopefully also something which more people than just one are happy to claim their own in sort of a co-authorship, if you will, because that is, I think, what new generative design strategies should enable, is co-authorship. You design not an end product, but you design an environment where people can create their own strategies and solutions, or collaboratively design them together. I just want to end quickly with a current project, which is linked to my PhD, where we explored this idea much more extensively. So the idea here is that we want to take care or address the current crisis that we have, and understanding that the construction industry didn't really make big advancements. So we created a new design environment where additive manufacturing can be used. I'm sorry for the bit of jittery resolution, but we developed new slab systems, if you will. We have different varieties. This one is a waffle flap structure, and we want to explore more efficient ways of how we can create those slabs. And one of them is to create formworks, which will be kind of placed and they like stay in that slab, and use additive manufacturing to create them. And this is a system that has actually been explored already extensively. But one thing that you will see comes again is the acoustic part. So we said that not only can we design those elements, but on a very, very small scale, we can induce some more intelligence in them. For example, having sound absorption qualities of those formwork pieces, so we don't need retrofitted acoustic ceilings. And that is something that we tested, and basically have like multifunctional formwork pieces, and then we fabricate them. Sorry, this video is jumping a bit. I apologize. We did this kind of first mock-up. We are now building currently other variations of this. And the idea was here also to have the opportunity that non-experts can use the program that we kind of showed here. And the way that we did it, I hope this will be shown. The way that we did it is we understood that robotic fabrication, for example, and can be very, very challenging. And we created or are creating a setup, a digital setup, where non-experts can actually see what the robot is going to produce and how it's going to basically move along to create this piece. They can interact with it, see basically if there's any collision problems, because one of the things in robots is you don't really see what's been currently doing. You can now simulate it in the digital realm, but we wanted to really put it into the physical or cyber physical realm to see what actually the robot will be doing. And the same thing we are exploring now with the assembly process as in the other example, but now on a bigger scale, where you have these subcomponents and you have them tagged with Aruco markers and basically can position them and get some more information, like what the weight is. Can I carry that alone, or do I need a colleague for that? Which level would that be? And a bit more of a meta information as you go along. And this is something that we're currently developing. So I'm sorry that I can't show you a bit more of a better resolution of the current design process. It's a video here, but I'm going to basically skip it. I think the main idea is there. And I really just want to thank you for listening. And I hope this was a bit interesting. And to just, again, finalize, through all the experiments that we did, the most challenging thing that I think we needed to address is, again, coming back to user interfaces. if we really want that other people and non-experts use our new capabilities, which is generative design, not only to create super interesting structures, but to automate processes, then we need to think about new ways of communicating this information and new ways to explore the variety of solutions in that space as well. So with that, I just really want to thank you again.
Thank you very much, Saki. It was
I think I need
really,
to
really.
quickly jump back to the teams.
So that was really interesting to see basically how much you came with generative design these days. And what I saw and I loved was your focus on intuitive user experience, because that's also the bread and butter in software development these days. And what I also really loved was this idea of adaptive design. That you can basically adapt the design and see the effect of this adaptation. But just for me as a naive civil engineer, the generative design is not a new concept, right? It is, if I recall, was 1970s with Gerald Dillon's paper, which basically the first time the concept of generative design was mentioned. So how do you think it evolved until today? So what is the main difference of today's generative design and 1970s generative design?
Okay, I hope the sound is okay.
Yeah, perfect.
Okay, so excellent question. I'm a bit biased because I'm an architect. I can only maybe say from my view, but I think when I was studying parametric or generative design was all about forms, new ways of creating more uh, interesting and complex geometries. I think it basically goes back to early studies that Frank Gehry did, Eisenman did, or Hadid and Patrick Schumacher did. So the way that I learned about generative design is about geometry. What I think now changed is the current crisis that we have, and we have to understanding that our resources are limited, and we really need to make an impact of embodied carbon that we produce with our buildings. And what I see basically is that generative design is used more and more for optimization and automation skills. So understanding if we have a building, can we create a very fast life cycle assessment? Can we optimize the structural performance, the acoustic performance? How can we streamline the construction so we have less resources that are wasted? And I think the realization also here when I teach our students is the same. It's interesting that they themselves say, hey, it's not all about the geometry or like crazy designs. Actually, we have to solve problems right now. The biggest problem is the way that we construct so far is maybe has led to a lot of challenges. And a good idea would be maybe not to continue this path. And I think generative design and automation are the keys to understanding what capabilities we have to assess our design and to optimize our design to a more beneficial and sustainable future, basically.
Yeah, understood. I think we again have problems with the sound. I don't know how we can fix it, but yeah. So I just think we can go with. Can you reroute your sound again? Are you listening on Teams, right?
Yes.
Okay, I think that's the main problem. Or turn down the volume a little bit. I think that should solve the problem. So we have one question. Can you shortly explain what workflow you used for the last project you showcased? What tools you used to optimize the form, shape, and ceiling blocks? And what was the key learnings during the process from anonymous user?
Um, that is an excellent question, and it can be only explained in different scales. So you have what we call macro scale, which is the overall building to access the structural performance of an entire building, breaking it down to its subcomponents like slabs, which is the we call meso level. And then we have the micro level, where we would define the individual pieces that we actually fabricate. So in terms of the macro and meso level, we used normal means like Karamba 3D to do first early investigations. And again, another tool that we used was FAM to do a bit more of more evaluations that we can't do with Karamba 3D or linear methods. Another thing is that the main work that we did was to understand how 3D printed elements behave because they have a fresh state and a hardened state. The fresh state is when we basically print them to currently print. Of course, they're not hardened and they have different properties. And for that, we also have to understand with material scientists the performances of the material and what capabilities are of the material. And this is again, that of course, you can use Karamba, you can use FAM for like investigations, I would more call them, but you need material scientists that actually do tests on the material itself, which is kind of also time consuming, but yeah. Now I don't hear. Yes, sir.
Yeah, I hope that answers the question. And what I also really loved about what you talked about was this idea of democratization of high tech design for everybody and make it accessible to everybody. Which, if we all basically go digital and embrace the digitalization, that's the whole idea behind digitalization. That this high tech should not be hard to use. It might be hard to grasp, but it should be as intuitive as possible, as easy to use, and accessible to everybody. Because with that, then we can say we made this digital transformation, and we are now in a place that everybody can use the newest technologies. Everybody can collaborate in the design. You don't need highly specialized people to sit and click through stuff. They can basically put their efforts on more cognitive and more creative stuff instead of doing repetitive tasks. And with that, I think we can also present a little bit what we do in our school. That's basically the main point of why we started the school. And thank to Zakib and to Christopher and Jacqueline and our trainers. This is basically uh, the school where we train people for very hands-on and real-world problems to solve very real-world problems with solutions and learn how to automate, why to automate, and how to automate. And we started with Autodesk, Revit, and Dynamo. And we have basically these four trainings on Autodesk, Revit, and Dynamo. And we started now with also with help from Sakib, the automation and Rhino series. The first one is almost ready. The next ones are also coming very soon. So we will have a similar palette of trainings for automation and Rhino as well. And basically the whole school concept is structured in a way that we have automation series for different environments. Then we have coding series, which are a little bit more hardcore on the coding side. And then we have data series, which are basically focused on data science, data interoperability, and data engineering. And the main focus, again, is to be really hands-on, to be addressing real-world problems, and to be taught by the practitioners of our industry and by doers, not only talking about academic stuff. It is very, very hands-on, and by people who've been there, who've done that, and who've burned their hands, I would say, a couple of times with the problems and know exactly what they're talking about. Any other questions from the audience? There's another question from Ramon. He asks, how do you get the Rhino environment into augmented reality? Is there an out-of-the-box tool to create real-time interactions?
Yes, I hope the audio is okay. So in Rhinoceros and also in Revit, we have already plug and play tools that you can use. One for Rhino would be, for example, Hologram that allows a very good access to augmented reality applications. Rhino inside is also something very interesting that allows you to build now bridges to gaming engines like Unity and also Unreal Engine, allowing to streamline those processes yourself. So this is exactly what we are currently doing. We are trying to create our own environment using those tools that I just mentioned, to just have more access to settings that we want. Because Hologram, again, if you have something as a solution already pre-built, you are limited to that instructions that you give in that system. So we want to explore this idea a bit more and be a bit more free to create our own user interfaces and the way that the geometry is also displayed. But Hologram, for example, and Enscape, also for Revit, would be good starting points to engage with those technologies.
Yeah, great. Yeah, I think these days you can't have Revit without Enscape. But yeah, and Ramon also asks if we have ArchiCAD GDI automation series. Yes, we are in the process of creating them, and Q1 2024 we would have also a set of ArchiCAD GDI automation series. But if anybody is interested in the school and the new trainings that we release, feel free to drop me a line. I will add you to the info list. We have a newsletter for friends and family, which basically we announce once a month or so the new stuff that we are doing in the school and the new trainings that are on the way. So we can keep you informed. Any other questions? Okay, great. I think you've done a great job, Zaki. Nobody has questions. Everybody is amazed by the great stuff that you guys are doing. And yeah, and just for your info, I was recording this session, so it would be also available on our YouTube channel. I will also post the link to the YouTube channel in our LinkedIn page and in the event as a comment. So you can basically view this afterwards as well. And I will also try to find a way to maybe post-process Zakib's audio, so we can basically have a little bit more tangible audio also for the Q&A session. So, and with that, thank you again for joining us, and I hope to see all of you for the next session as well. And Zakib, thank you again. It was a pleasure, like always, and thank you also for all the heavy lifting that you're doing for the school. And yeah, wish you all have a nice evening or day, wherever you are. Take good care. Bye. So, jetzt.